We are now going to demonstrate how to multiply a vector by its transpose. If you refer to video 3.5 on simple matrix multiplication, where we multiply two vectors together, you can learn how to do this. So let's have a vector R. It's a column vector, 6, 1, 2. It's a 3 by 1 matrix, but we'll just call this vector R. And the transpose of R is going to turn this column just into a row, 6, 1, 2. Which is a row vector. We'll just call it the transpose of R, and it's a 1 by 3 matrix. Now when you multiply these two together, let's first take the transpose of R times R. We have a 1 by 3 matrix, and we multiply that by a 3 by 1 matrix. So the resulting matrix is going to be a 1 by 1 matrix. And as you recall, this is just a simple number, and we call it a scalar. So let's demonstrate this. R transpose times R, 6, 1, 2 times column vector 6, 1, 2. And we get 6 times 6 plus 1 times 1 plus 2 times 2. Simplify that, 36 plus 1 plus 4, and that will give you 41, which is a scalar, but we actually call this a dot product. I want you to remember that when you multiply a vector by its transpose, actually when you pre-multiply the transpose, and then you get the dot product. Now let's do the other one. You can have R times R transpose. R is a 3 by 1, transpose is a 1 by 3, so the resulting is a 3 by 3 matrix. So let's demonstrate that here. R times R transpose. Six, 1, 2. 6, 1, 2. Remember, you take the first number in the first row and multiply it by the first number in the first column of the second one. So 6 times 6. Now, we stated before that when you multiply matrices together, you're getting the sums of products. Well, since you only have one number in each one, there's really nothing to add up besides these first numbers. So you're just taking the first product there. So 6 times 6. And then take this first number and multiply it by the second number in the second column. Right there. So 6 times 1. And then you'll get 6 times 2. And do this for the second row, which is just the second number here. 1 times 6. 1 times 1. 1 times 2. 2 times 6, 2 times 1, and 2 times 2. Now I like to check to make sure I have it right before I continue. The way to do that, once again, is look at this first row, and you have a 6, so you should have a 6 throughout the first row of your resulting matrix. 6, 6, 6. Then 1, 1, 1, 1, 2, 2, 2. Now look at the first column here. You have a 6, make sure that's in the first column of your resulting matrix, 6, 6, 6, 1, 1, 1, 2, 2, 2, so we can continue and simplify. 36, 6, 12, 6, 1, 2, 12, 2, 4. And we actually call this the matrix product. So when you do R transpose times R, you get the dot product. R times R transpose, you get the matrix product. Now as you notice, we've mentioned this before, matrix algebra does not follow the commutative law, which states that A times B equals B times A. But matrix algebra, matrix A times matrix B does not equal matrix B times matrix A. And proof of that is the dot product and the matrix product as the resulting matrices you get there. So let's demonstrate this in Excel. So we have our R matrix, which is 6, 1, 2. And if you remember how to take the transpose, you just copy that, and you're going to do a paste, paste special, transpose, and you get 6, 1, 2. So now we're going to do R transpose times R. These are matrices, so you're going to do equals matrix multiplication, M-M-U-L-T, open parenthesis, take R transpose first, comma, R, close your parenthesis. What do? Control, Shift, Enter, and you get 41, which is what we got over here. So let's do the other one. R times R transpose equals matrix multiplication, parenthesis, first one, comma, second one, close your parenthesis, and Control, Shift, return. And so you notice these are the same matrices, so that's how you do it by hand, and that's how you multiply a vector by its transpose using Excel.